Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 122. Best time to buy and sell stock 2. You are given an integer array prices, where prices I is the price of a given stock on the ith day. On each day, you may decide to buy and or sell the stock. You can only hold at most one share of the stock at any time. However, you can buy it and then immediately sell it on the same day. Find and return the maximum profit you can achieve. Example 1. Prices equals 7, 1, 5, 3, 6, 4. The output is 7. If you buy on day 2, when the price is 1, and sell on day 3, when the price is 5, you gain 4, profit equals 4. And then buy on the day 4, when the price is equals 3, and then sell on the day 5, when the price is equals 6. Then the profit is 3, and then the total profit is 4 plus 3 equals 7. In the example 2, if you buy it on day 1 when the price is equals 1 and then sell on day 5, then the profit is 4. And then in the example 3, since this is a decreasing array, the output is 0 because there is no way to make a positive profit. So we never buy the stock to achieve the maximum profit of 0. That is our default. So we never buy. So how to solve this problem? So let's take a closer look at the example. When we went through the example, did you find any pattern? Let's say, take a look at example 2. This is a strictly increasing array. So in that case, we know we buy on the first day and sell on the last day. In that case, we gain the maximum profit of 4. So this is actually equivalent to we buy it on day 1, sell it on day 2, and then buy it on day 2, sell it on day 3, and then sell it on day 3, and then buy it on day 3, and then sell it on day 4, and then buy it on day 4. Because we can buy it and then immediately sell it on the same day. So it's the same as you can sell it and then immediately buy it on the same day as well. So in that case, we find that, okay, from example 2, we realize that, okay, purchase on the day 1 and then sell it on the last day, day 5, is equivalent to purchase on day 1, sell on day 2, and then purchase on day 2 immediately, and then sell on day 3, and then purchase on day 3 immediately, and then sell on day 4, so on and so forth. So that's kind of one of the pattern we find. And then let's take a look at the example 1. So in the example 1, we are not buying it on day 1 because if we buy it, because day 1 we have the price equals to 7. So rather we want to buy it on day 2. So when the price is 1, and then we sell because on the day 3, because in this case on the day 3 the prices is greater than the day 2. So if we purchase on day 2 and then sell on day 3, then we guarantee to make a positive profit. So we accumulate a positive profit. And then after that, we can accumulate positive profit by, okay, purchasing on day 5 and then sell it on purchases on day 3 and then sell it on day 5. But in that case, we only accumulate a positive profit of 1. So in that case, later we find, okay, there's a better option because on the day 4, we got the prices equals 3. So if we purchase on day 4 and then sell it on day 5, we make the positive profit of 3. So in that case, we accumulate the total profit of 7. So have you find the pattern here? So it's actually equivalent to, let's say, okay, we can have a strategy, which means, okay, for each day, we compare our profit with the previous day. For each day, we compare our price with the previous day. Let's say on day 2, we know that the price on day 2 is less than the price on day 1. So in that case, buy it on day 1 and then sell it on day 2 is not possible because it will not give us the positive profit. So that's not a valid strategy. And then we check the prices on day 3. that's 5, and it's greater than the price on day 1. So in that case, if we purchase on day 1, if we purchase on day 2, and when the price is 1, and then sell it on day 3 when the price is 5, we are guaranteed to make positive profits of 4. You may say, okay, what if, like, let's say we purchase on day 2 when the price is 1 and sell it later? That's actually equivalent to when we purchase on day 2 when the price is 1, and then sell it on day 3 when the price is 5, and then immediately purchase on the same day and then sell on the later day. So that's what we find from the example 2, right? So in that case, we can just like say, okay, we can it's safe for us to assume that, okay, the strategy, let's first purchase on day 2 and then sell it on day 3. And then when we look at day 4, so we know that, okay, day 4 the price is 3, and which is less than the previous day price. So we cannot purchase on day 3 and then sell it on day 4 to make positive profit. So in that case, let's move to the next one. Let's say, okay, how about day 5 and then compare it with the price on day 4. So if we purchase on day 4 when the price is 3 and then sell it on day 5 when the price is 6, we are making a positive profit of 3. So that's a bad strategy. Now we accumulate profit of 7. And then we have the last element in this process already left. That is the last day when the price is close 4. So in that case, it's decreasing. So we can now purchase on previous day and sell it on the current day to make a positive profit. So in that case, the total profit is 7. So that's kind of our strategy and our solution. So let's code it up. So basically we are trying to, okay, we need to have something to actually keep track of the total profit. And then initially it's equal to 0. And then we check every element for price in price, for let's say for I in range prices 1 and length prices. If prices I is greater than prices I minus 1. If the current price is greater than the previous day price, which means, okay, we can purchase on previous day and sell on current day to make a positive profit. So in that case, we add that to the total profit. Else, we are just not going to do any transaction. So in the end, let's just return the total profit. Let's try to run the solution. Okay, so this solution is actually pretty efficient.